Welcome back to the part 4 of this SwiMove course. In today's lesson, we'll learn about SwiMove security and tests. So first of all, we'll learn about the smart contract and also the SwiMove security. Then we'll give you the introduction to the unit test and how to run those unit tests. And finally, we'll introduce a new way to run the Swiss-specific testing method. Okay, let's start with the smart contract security. So complex blockchain technologies like Sui and Ethereum are still in their infancy. Therefore, you should anticipate ongoing changes in the security environment when new vulnerabilities, security threats, and best practices are identified. As a smart contract developer, your efforts on security will continue after you follow the security guidelines in this course. Programming smart contract necessarily has different technical mentality than you might be accustomed to. In some aspects, it's more like a hardware programming or financial service programming than web or mobile development. Because the cost of failure may be significant and change can be challenging. Therefore, simply defending against known vulnerabilities is inefficient. You need to study a new philosophy instead. So let's consider this attack, for example. In 2016, 150 million worth of Ethers was drained from the DAO smart contract by reentrancy attack, and this has led to the hard fork of the Ethereum blockchains. So basically, you can define a fallback function in every smart contract and execute any functionality you like. So the hacker used such smart contract to withdraw the funds from the DAO, and within the withdraw function, it calls the fallback function, and which will call the withdraw again. So in that way, this results in the hacker drained that much Ethers from the DAO. And we call this type of vulnerability reentrancy attack. So how to write the secure smart contracts anyway? Well, you should follow the best practice to ensure your codes are in the high quality. And second, you should test your codes thoroughly. So you should write the unit test and also the integration test with high coverage. And finally, you should do the code review and auditing. So that will make the codes being reviewed and also audited by the security auditing firms like MoveBit. Except for that, you can also use the security tools and also the bug bounty programs. So security tools will help identify vulnerabilities, such as static analyzer, also the linters, fuzzers, and formal verification tools. And after your project has been published on the mainnet, you can also consider running the bug bounty program to encourage external security researchers to find and report vulnerabilities. Okay, let's introduce unit tests. Unit tests are typically tests that developers run to ensure a section of an application meets its design behaviors. In Sui, unit tests will begin with a test annotation, and you can call it with the SwiMove test command. So the unit testing for Move adds 3 new annotations to the Move source language, which are test, test only, and expected failures. They respectively mark a function as a test, mark a module or module member as code to be included for testing only, and mark that a test is expected to fail. These annotations can be placed on a function with any visibility. Whenever a module or module member is annotated with test only or test, it will not be included in the compiled bytecode unless it is compiled for testing. For the test annotation, without the arguments, the test annotation can only be placed on a function with no parameters, and this annotation simply marks this function as a test to be run by the unit testing harness. And for the expected failure, a test can also be annotated as it. This annotation marks that a test should be expected to raise an error. You can ensure that a test is aborting with a specific abort code by annotating with the abort code inside of this annotation. And if it then fails with a different abort code, or with a non-Borel error, then the test will fail. Other functions that have the test annotation can also be annotated as an expected failure. And the test-only annotation, in such a case, the item will only be included in the compile move bytecode when compiled to the test mode. Additionally, when compiled outside of the test mode, any non-test use case of the test-only module will raise an error during compilations. Alright, let's try to run some unit tests here. So this is a pretty simple game module called MyModule under the MyFirstTest package. And you have like the sword and also the forge. So you can create your sword here and also transfer your sword to others. And this is a test function to test if we can create a sword and also, check if the accessor functions return the correct values. And finally, we'll create a dummy address and transfer to that address. All right, so we will test this function using Sui move test and create. Well, you don't have to specify create here. I specify here because I have several tests and I just want to test this specific function. Building it and should be able to test my function. Okay, as you can see here, the test sword create has successfully passed the Sui move test. So that's good. And then, except for the simply test runs, we can also add some other subcommands. So let's explore those subcommands using helper. Alright, as you can see here, so it got a lot of like options you can choose. For example, the forces will force the recompilation of all packages. Also the coverage. So this command will collect the coverage information for later use. This is often used when you have a lot of like tests and you want to see which functions are covered and which are not. Okay, so let's try to use some of the commands here. So move test create statistics. So this subcommand will give us the detailed time and also the gas use for a specific test function. And yeah, as you can see it, so the test statistics has successfully showing a and it shows the time and also the gas use for my test or create function. That's good. Okay, let's then explore the Sui specific testing method. The previous testing example is largely pure move and isn't specific to Sui beyond using some Sui package, such as Sui transaction context and Sui transfer. While this style of testing is already useful for writing move code, you might also want to add additional Sui specific features. In particular, a move call in Sui is encapsulated in Sui transaction, and you might want to test transaction between different transactions within a single test. Sui specific testing is supported through the test scenario module that provides Sui related testing functionality, otherwise unavailable in pure move and its testing framework. So let's say the testing scenario. So the testing scenario module provides a scenario that emulates a series of Sui transactions, each with a potentially different user executing them. So for example, like the address 1 and address 2. A test using this module typically starts the first transaction using the test scenario begin function. This function takes an address of the user executing the transaction as its argument and returns an instance of the scenario structure representing a scenario. An instance of the scenario structure contains a per address object pool emulating Sui object storage. With helper function provided to manipulate object in the pool, After the first transaction, subsequent test transaction starts the test scenario next transaction, and this function takes an instance of the scenario and also the address of the user as arguments. So here is the full test using test scenario upon our module, and we'll delve into its details. So first of all, the code does is to create some address that represents the user participating in the testing scenario. The assumption is that there is one game administrator and two regular users representing the players. The test then create a scenario by starting the first transaction on behalf of the administrator address. So as you can see here, begin with the admin role. And in the previous code, we used test scenario begin function, which will begin a new multiple transaction test. Well, the CTX is just a simple getter function that will return the mutable transaction context. And the administrator executes the second transaction, as you can see here. So the transaction creates the sword with the specified value 42 and 7, and then transfer it to the initial owner. So next transaction is a function that advances the scenario to a new transaction, where sender is the transaction sender, and all the objects transferred will be moved into the inventories of the account, or the global inventory. So the initial owner will then execute the third transaction, will then transfer the sword to the final owner. And in pure move, there is no notion of sui storage. Consequently, there is no easy way for the emulated sui transaction to retrieve it from the storage. This is where the test scenario module helps. The take from sender function here allows an object of a given type that is owned by an address executing the current transaction to be available for move code manipulation. So for now, assume that there is only one such object. In this case, the test transfers the object it retrieves from the storage to another address. And the transaction effects, such as object creation and transfer, become visible only after a given transaction completes. For example, if the second transaction in the running example created a sword and transfer it to the administrator's address, you only become available for retrieval from the administrator's address in the third transaction. So the take from sender function, as we mentioned, is a very helpful function that can directly operate over the transaction sender and take the object. Then the final owner will execute the final transaction and checks if the sword has expert properties as we desired. Then it will give back the sword to the object pool and end the scenario. Alright, so end function will just end the test scenario and returns the result from the final transaction. Now, if you run sui move test again, you'll see that both our tests will pass. Okay, it's time to finish the exercise. So we added two new functions, sword update and sword burn, to our previous module. Now you'll need to test them out. So firstly, you'll write a test sword update function that will emulate module initialization, create the sword, update the sword values, and check that the access values are updated. Then you'll write a test sword update function that will also emulate module initialization, create the sword, and burn the sword. And finally, you should run the sui move test and pass all the tests you write. You should also check our template code here. So this is our template code. We have added two more arrow codes here where you can use in your module functions. So here is the sword update, and here is the sword burn. You'll need to write the test for both functions. So the notice that using arrow codes is encouraged but optional. And also you should use a sui test scenario to construct the test. And for the test or burn function, you do not need to use the test scenario return to sender function because it's already burned. Alright, so that's the end of this lesson. I hope you enjoyed with it.